All right, so here's another ugly looking integral that we're going to try to apply some trig substitution to in order to solve it. So here I've got x squared plus 4. So I'm seeing something squared plus a constant. So I'm thinking a tangent substitution would make sense. So I'm going to let x equal to tangent of theta. Okay, so then dx is equal to 2 secant squared theta d theta. Okay, so all right, let's let's see what we can do with this. I'm just going to substitute in and let's see what happens. It gets a little ugly at first, but we'll be able to use some trig identities to clean it up. So I have the integral of 1 over, okay, got a lot of stuff here in the bottom. I've got x squared, so that becomes 4 tangent squared theta, and then I have this square root, and again I have x squared, so that's 4 tangent squared theta plus 4. And then, okay, we got to substitute in for dx, and so dx is equal to 2 secant squared theta d theta. All right, now let's start cleaning this thing up. I'm going to, first of all, I've got this 4 in the denominator, and so I'm just going to pull out 1/4. And then I've got 1 over, I've got tangent squared theta, okay, and then I can also pull out the 4 from underneath the square root. I'm just going to put that there. It becomes 2. And then this will be tangent squared plus 1. So tangent squared plus 1 is secant squared, right? And then the square root of secant squared is just secant. So this becomes secant of theta. Okay? I kind of combined a lot of steps in one, right? I pulled out the 4, made it into 2, and then I took the square root of 1 of tangent squared plus 1, which is secant squared. The square root of secant squared is secant. All right, and then, so that's still times 2 secant squared theta d theta. Okay, now I'm seeing this 2 here. I can cancel. And also I've got secant times secant in the numerator here, and then I've got secant. So I can actually cancel one of these secants out. So instead of having secant squared, I'm just going to have secant on top. All right, well that helps a little bit. So let's rewrite it and see what we got here. So 1/4 integral. All right, I don't really like having this tangent in the denominator. So I know that tangent is sine over cosine. So 1 over sine over cosine squared. I'm just essentially going to get cotangent squared. So I'm going to write it as cosine squared theta over sine squared theta. Okay, so that's all I have in this fraction here. All of this whole fraction is just 1 over tangent squared, and I can make that into cosine squared over sine squared. And then since I've got that in terms of sine and cosine, I'm just going to write the secant in terms of cosine, right? Because secant is 1 over cosine. So I'm just going to write this as 1 over cosine of theta, right? And then we still have the d theta. And then you can see one of these cosines is going to cancel out, right? So then I just end up with cosine theta over sine squared theta. All right, so to me, whenever I see, I can combine this cosine theta with d theta, right? So if I do a substitution, just a simple substitution, and I'm just going to let w equal sine of theta, all right? So now I'm not only doing trig substitution, I'm also doing just regular simple substitution. Then dw is equal to cosine theta d theta, and I can see I've got that in the numerator, right? I've got this cosine theta times d theta. All right. So if I make that substitution, then I have 1/4 integral of 1 over w squared dw. And I can easily integrate that, right? So it's just, it's basically w to the -2. So then I will get, that becomes, so I've got 1/4, and then this becomes basically minus w to the -1, right? And then plus c, okay? And, or I could write it also as minus, let's see, whoops, I accidentally put a minus in there. That shouldn't be there, right? Because I had the, whoops, the minus was inside already. So that just kind of snuck in there. So I end up with, anyway, minus 1 over 4w plus c. All right. So now let's go back to theta. All right. So let's put, so this is, if I, just, I know that w is sine theta. So this becomes minus 1 over 4 sine of theta plus c. Okay. So I have my integral in terms of theta. All right. So I'm getting close. The problem is that, up here, I let x equal to tangent theta. So tangent theta is equal to x over 2. So theta is equal to the arctangent of x over 2, right? But if I plug that into sine, it just isn't real nice. It's just not a nice, I prefer to not to write the sine of the arctangent of x over 2. I could. That's just kind of ugly. But I can use another sneaky little trick here. And because if I draw a triangle, a right triangle, where theta is one of the angles, and I let, so tangent is x over 2. So I can make this side x and this side 2, and then the tangent of theta is x over 2. And I can use the Pythagorean theorem to figure out what the hypotenuse is, right? So the hypotenuse is going to be the square root of x squared plus 4. All right. So now I can actually find sine of theta just from the triangle. So sine of theta is opposite over hypotenuse. So I'm going to get x over the square root of x squared plus 4. All right. Okay, so now I know sine of theta. So let me scroll down just a tad here and make a little more room to write. So, so now if I substitute that in, I can get this integral in terms of x. So I'm just going to make this minus 1/4 out front. And then I basically have the reciprocal of sine. All right, so I'm going to take that times the reciprocal of sine, which is what I have here. So square root of x squared plus 4 over x, okay, and then plus c. And that's it. That's the result. And we have it now in terms of x. So that shows you another sneaky little trick, is to use the triangle to find if you so we made let me just recap what I did here. We made x equal to 2 tangent theta, which means tangent theta is x over 2, but we can find the other trig functions of theta using the triangle. So we just make a triangle in which the tangent is x over 2, and then we can find the hypotenuse, and then we can get all of the trig functions for theta. All right, that was sneaky. So there's one more topic I want to cover here, so I will meet you in the next video.